All right, let's write this summation out just to see what's happening here. So I can see that I have a 15 divided by n. I'm going to bring that out front. And then when k equals 1, we would get h prime 15 over n times 0. Then the next term, when k equals 2, we would get h prime 15 over n times 1 plus dot dot dot. If we go to the end here, we would get h prime 15 over n times n minus 1 for the last term. Okay, so what do we notice here? Well, we can see here that this is going to be our x values. All right. So we know that the first term, if you had 15 over n times 0, we would get 0. Then the next term would be 15 over n. And then the term after that would be 30 over n, all the way to 15 over n times n minus 1. Okay? Well, so what is the change? What is the dx? Well, we can see that we're going up by 15 over n each time. So that's my dx. Okay. Well, what else do we know? Well, we know that the first term here is 0, right? So what's happening, if we set up our definite integral, we would have 0 as our first, the lower limit of integration. And then what's happening at the end? Well, if you took this n term and you multiplied that out, you get 15n minus 15 over n. Well, what would happen if you took the limit at infinity here? Well, if you took the limit at infinity here, this value would come out equal to 15. So that means my upper limit of integration would be 15. And then what's happening here is we have h prime x, and then our change in the interval is dx. So we have our answer.